All right. And once again, we'll talk about similar objects together. We're going to do prisms and cylinders together because the formulas are going to be very much the same because those two objects have two bases that have to be the same. Remember, sometimes with the prism, though, they kind of tip it over on you, so you got to be careful as to what that is. On yours, are the formulas already in there? Yes, they are. Next year, they will not be. Volume is, somebody had fun switching my things around. Area of the base times height is basically what that stands for. Because when you start seeing capital B, that's area of base. And h is height of what? This is the part that's getting some of you. This h right here has to be the height of the prism. Is it very possible that when you're over here finding area of the base that there will also be a height in that formula over there? There is, and you have to make sure, well, which height am I looking at for this particular problem? Technically, the formula is the same over on the other one, but for some reason it doesn't look the same. Why is it pi r squared h? Well, what is going to be the area of a base? If you have a cylinder, it's a circle, which is pi r squared. So all they did, again, is specialized it because they can. Over here, we can't. Prisms could have a triangle down there, a pentagon, a square, and all of those have different formulas, so it can't be specific. And your job is to figure out what you need for each problem. Okay, any questions so far? This picture is a little bit better than the one that you have on your notes, so if you are confused at all on the picture that you have, just look up here. It's a little bit more helpful. Is this particular prism sitting on its base? Nope, this one's been tipped over. The bases are the, what objects are they? Triangles, and if you were confused, you could have looked right here. Oh, it's supposed to be a triangular prism. And so you should be looking at the triangles. Well, we're going to obviously use the prism formula then, and it does say to find volume, so we should probably do that. So maybe down here, let's find the area of the base. And then you just told me it was a triangle. We'll just draw that down here. So this bottom part is 12, right? And how about this piece over here? The hypotenuse is 15. Very good. Now, how about the other piece, though? It is 9. Now, how would you figure that out if you didn't know? Use Pythagorean theorem, but really all it is 3, 4, 5, that triple. All times 3 is what it is, okay? So it is 9. Is everybody okay with me just writing the 9 there? Kind of, you would be able to figure that out on your own, okay? It'd be a squared plus b squared equals c squared, or it is a triple, technically. So to find, let's just kind of forget about that right now. This is where some of you get in trouble. Let's just worry about this right here. Okay, to find the area of that base, we would take base times height and do what? Divide by 2 is how we would find the area of that. Does this height that's in this particular formula have anything to do with the height of the prism? Not a thing. So maybe, again, cover that prism up while you're doing these, and then maybe it'll make more sense. And in these area formulas, the base and the height will always come together at a right angle. So in other words, this one here and that one there are coming together at a right angle, so those are your base and your height. So what do we got there? 12 times 9 divided by 2. And so basically, what do we get when we do that? It's basically, the way I look at it is 6 times 9 is kind of how I look at that. And we get 54. Well, 54 what? Centimeters squared, because I took, and I didn't write it in there because I took centimeters times centimeters and divided by 2. So it is centimeters squared. Now what I can do with that is I can come up here and say my area of the base is 54 square centimeters. Is all they wanted area of the base? It'd be nice if that's all they wanted, right? Because we'd be done. But that's basically the base part of the formula. Now I have to take it times the height. Well, is the height like it was down here? Is it 9 like it was down in this formula? No, that height is now when you return to your prism and say, okay, if I'm over here, the height of my prism is 10. Okay, so we take that times 10 centimeters, correct? 540 is correct, but now here's where, once again, you have to start kind of changing how you think. I know a lot of you go by default, oh, volume is units cubed, but why? Because I just took centimeters squared times another centimeter, so it is centimeters to the third. Now, what I'm going to show you right now only works for cubic centimeters. Okay? Cubic centimeters actually has 3 acceptable labels. Okay, and sometimes this may help you once you get to chemistry, knowing that there are 3 acceptable labels to cubic centimeters. Some of you I know have seen this one before. You could write it as cc's, because that's what cc stands for, cubic centimeter. Very acceptable, same thing. Again, this only works for that. And one other one, this is the one that may help you in chemistry, is a cubic centimeter is the exact same thing as a milliliter. They're exactly the same. And do you agree that in chemistry, milliliter measures volume? You have those little beakers, right? And so all 3 of those answers right there would be acceptable to this problem, because all those labels are equivalent. You might want to write that off to the side, that cubic centimeter, cc, and milliliter, all the same thing. So all of them would be acceptable. So any questions how we use the volume formula, though? Pretty straightforward. As long as you can keep this height down here that's in the area formula separate from that height of the prism. If you can do that, you're probably going to be all right. Okay. This one's an interesting one, so why don't you read through it quick? I know some of you are thinking the football field is not 65 yards wide, and you're correct, it's about 50, but I'm doing the sidelines too. So we're going to dig it out 6 inches deep. We're going to come in and bring some sod. So some pretty thick sod apparently, but 6 inches is just going to work better in this problem. All right, just trust me on that one. Cubic feet of dirt necessary to fill it. Well, what would that look like? What kind of figure would that be? Well, if we dug it out, it basically turns into, let's say we were like, able to telekinetic and we were able to lift all that dirt all at once. That's what it would look like, right? If we were able to do that, obviously we can, but that'd be nice if we could. And basically we're digging it 6 inches deep, so 6 inches would be right over here, and then it would be 65 yards that way. And does everybody agree that it is 120 yards? That does sometimes give cause for question. Some people say it's only 100, but you forget the end zones. All right. Does anybody see a possible problem here? Do we potentially have an issue here? Yeah, when we take inches times yards, what are you going to label that? Square yards, inches? Well, that's what you'd have to label it if you leave it like this. Have you ever heard a label like that? No, so we should probably get them at least all the same. So before we even start this particular, it's a prism, rectangular, right? I would say this one's sitting on its base. Remember, that's what I told you to do with rectangular ones. Let's get it all the same way, and let's look at the question. It wants my answer in cubic feet, so why not get everything to feet? Doesn't that make sense? So I know that 1 foot is how many inches? Is 12, correct? So how many feet, or what part of a foot is 6 inches? Okay, that's where I went with 6 inches. It was a little easier than if I would have gone with something else. So you do agree this is 0.5 of a foot right there. You agree that's the same thing for that label? Yep, okay. Now, 1 yard is how many feet? 3. So I've got 65 yards. So 1 yard is 3 feet, so 65 yards must be 190. You got to take it times 3, right? So 195 feet. Everybody okay with how I'm changing these? Is that all right? Now over here we have 120 yards. So 1 yard is 63 feet. So 120 yards is how many feet? Here it is. 360. So now do we have everything at least with the same label? And if I take feet times feet times feet, will I get cubic feet? I will. And that's what we wanted anyway. So now we have to decide, well, we need volume. I know it's just dirt, but it's still volume. So it's area of the base times height. Well, what is my base this time? What object are we looking at as our base? Yeah, a pretty big rectangle, right? So our area of the base is basically a really big rectangle. That is what, 65, whoop, we don't want to use that measurement, right? 195 feet by 360 feet. Do you agree that's what would be on the bottom? Well, that's big. How much is that? You got to take 195 times 360. That's getting rather large in a hurry. Anybody have that number? 70,200. And what's the label on that? That's a horrible 7. But anyway, feet squared. All right, so if we're up here, you agree that our base is 70,200 square feet. That's the area of the base. Now I have to take it times the height. The height of what? The half a foot, exactly. So times 0.5 of a foot. So is it going to get smaller then or bigger if I take it times 0.5? Smaller in about half, right? And so the volume in cubic feet is obviously half of that, which comes out to be 35,100. Now what's your label? You took square feet times another foot is, and is that what they wanted? Yeah. So that is what they wanted. I am going to take it one step further, because once again, how many of you believe that you have a good visual of 35,100 cubic feet of dirt? Okay, it's probably getting a little bit better, but I'm going to go even further. Plus, I want to teach the conversion anyway. Let's get to cubic yards. Do you agree that I have to divide by 3 every time I want to get something to yards, right? So if I divide by 3 for one dimension, divide by 3 in this dimension, and divide by 3 on this dimension, right? 3 dimensions for volume. It's not divide by 3. It's not divide by 9. It's divide by 27. 3 times 3 times 3. So divide by 27, and you will get. Now, some of you are saying that has nothing to do with this problem. You're right. This is the answer to the problem. This is me giving you a visual. Divide by 27, and that will be cubic yards. Because then I'm going to give you, hopefully, another visual that will help you. 1,300. Now, you might wonder why I went to cubic yards. Because I have a piece of knowledge that it might be helpful here. Everyone's familiar with a regular dump truck, correct? 10 cubic yards fit in a dump truck. So if we were sitting here, how many dump trucks would go by full of dirt to fill that hole we just made? 130 of them. We just keep on going, dump it, go get some more, go dump it. Now do you have a visual? Probably a little bit better than you just did. Okay. It's not those big Caterpillar ones, all right? It's just a regular dump truck going by. They hold about 10 cubic yards of something, all right? We're not taking out the whole curb and everything all the way out there. All right, so now you have a visual, and I'm trying to do that in this chapter. Any questions so far? All right, you do not have this visual on yours because I made it about 20 minutes ago. And I've been amazed throughout the years how many people did not know what a washer was. They were thinking of a washing machine. Not quite. I borrowed this washer this morning. It wasn't, obviously it's not a 1-inch washer. Well, hopefully it's obviously that this isn't quite an inch washer. Probably pretty close actually. Not quite. This is what a washer is. Okay. What this problem has, it has 150 of these. And they stack them one on top of the other. Okay. Almost like one of those things they might have on Minute to Win It. You'd have to stack 150 of these on top of each other without them falling down. But that's what this picture has given you, and what it wants is the volume of metal for one of them. But does it give you the height of just one of them? It gives me the height of all 150. That's the problem. Now I see a cylinder. I hope that you do as well. You may want to draw something similar to that in your notes. Do the best you can. I'll pause for a second here to give you a chance to do that. All right, hopefully that was enough time to draw your picture. Once again, keep in mind there are a lot of them in here. You know, obviously you could draw a bunch of them in there if you wanted to, but I think that's more than you need. When they say it's a 1-inch washer, how do they measure washers? Yeah, diameter, side to side. So basically this bigger one all the way across is 1 inch, correct? But then I've also told you that the diameter of the hole is 3/4 of an inch. Okay? So basically from here over to there is 0.75 inch. And give or take, I mean, if this was just a little bit bigger, it'd be relatively close to that same ratio at least, correct? And 9 inches tall for all 150 of them. So basically I look at it this way, like I told you. I see a cylinder inside of a cylinder. believe it or not, there is a hole there. That hole can have volume. What's it holding right now? Air. But it does have volume, correct? And then obviously the whole thing would have volume. My suggestion to you is let's pretend it was a completely filled object, find the volume of the whole thing, subtract out the volume of the hole. Does that make sense? Let's do that. Now this one is volume, so it's area of the base, which is pi r squared, times the height. So over here, let's do the volume of the entire thing, pretending it was completely filled in, no hole at all. So then we would go volume equals pi. What is the radius then? If it's 1 inch all the way across, radius is ½ an inch. Right? And then we have to square it and then take it times the height. This height, is that talking about the height of the cylinder or the height of something else? Height of the cylinder, and so that is 9. Now it's totally up to you. You can either get a decimal at this point or we can leave it at pi. Whichever way you want to do that is completely up to you. But I do need somebody, this is inches. So we are still taking inches squared and then times inches, so it is inches cubed. So somebody either go ahead, get the decimal, or leave it as pi, whichever way you would like to do it. I have no preference either. 2.25 pi. Should we leave it like that, or you want to go more decimals? It's up to you. So what is it? 7.1. Now that's no pi, right? So you took pi out of there. Now is that the answer to the question? Well, what did we just find? We found the volume of that whole thing, perhaps before they drilled the hole through it. Because that's, again, like I said, that's actually how they make them, and then they slice them off. They can do it that way. It's a little bit easier. Over here, the volume of the hole, or the air that's in there. So volume, pi. Well, the height's still 9, right? Of the air in here. This is a little bit trickier. What's the radius? It's 0.75 is the diameter. 0.375. Very good. You had to take that and divide by 2. So go ahead, use those calculators and give me this answer then. Do we expect it to be more than 7.1 or less? Better be less, right? Or we did something wrong. If our hole is bigger than the thing filled in, that's not good. Okay, so if you get something like 9, you might want to try typing it in again. Maybe move your decimal where it belongs. All right. Four? Pretty much just flat out 4? Rounded? Okay. Well, that's strange. The worst decimal came out almost to be a better answer. Yep, 4 inches cubed, because we did take inches squared. Oop, I didn't write them in there, sorry. Okay, so is 4 inches cubed the answer to the question? Oh. Well, now what then? Oh, we subtract. Okay, so we got to find the volume of metal. Okay, so 7.1 minus 4. I really hope you're not going to the calculator for that one. If you are, it's maybe work on that a little bit. And so now wait a minute. This was cubic inches and cubic inches. So what's the label going to be? Yeah, it's still going to be cubic inches. And what is it? 3.1. Now the question is, do I circle that? That's the volume of all 150 washers. Divide by 150. Is this going to be very much? No, not really. Not if you take this and divide by 100. Now, is that going to affect my label if I just divide by 150? No, it's not 150 inches. It's just 150. It's not much, and I think we can round that off. Yeah, 0.02, isn't it? 0.02 cubic inches. Once again, that's something that you probably don't have, because the big stuff you don't have a visual for, and the small stuff is probably just as difficult. I think this is pretty close, pretty good. It's probably a little bit more than this would work out. Actually, I borrowed it from Mr. Dickman. He had a little bit bigger one, but it was so thin I thought I'd break it, and so I thought I would bring this one instead. All right. That's what I thought. I don't know why they had it. Yeah. Okay, any questions on any of it? Like I said, example 4 is very similar to the other one, so do we need to do that one? It's very similar to the football one, so I think we're good.